Okay. Trigonometric complex numbers is not as intimidating as it sounds. Okay? You are going to see a lot of similarities with vectors. A lot of the math that we did with vectors, you will see in what we do with trigonometric complex numbers. Okay? So let's talk about what a complex number is, first of all. We haven't talked about them for a while. What does a complex number involve?
It's got an imaginary part and a real part.
It has an imaginary part and a real part. A plus BI. That is a complex number. Okay. So the first concept I want to talk about, well, here pretty soon will be the absolute value of a complex number. But first, I want to introduce you to the complex plane. Okay. The complex plane is made up of the real axis and the imaginary axis. This is just a way for us to graphically represent a complex number. This is not the XY plane. The XY plane is the real plane. This is the complex plane. They're two different entities. Okay? But I want you to be able to visualize a complex number so that when we find things like the distance from zero and angles of direction, we can kind of think about what we're finding. So if I were to graph the number 2 plus 3i, I would go right 2 on the real axis and up 3 on the imaginary axis. If I were to graph the number 5 minus I would have to go 5 in the positive direction on the real axis, but then I would have to go down 1 on the imaginary axis. Where would I graph the number negative 3i?
On the imaginary axis, you just go down 3.
We would just go down 3 on our imaginary axis. Okay. So, I want to talk about the concept of an absolute value. Okay? At your pod, I want you to think about this question and discuss it. The absolute value of negative 5 and the absolute value of 4. What are those values and what do they represent? I'll give you about 60 seconds to talk about it.
Well, I feel like
No.
All right. Pod 7. What are these values? 5 and 4. Pod 3. What do they represent? You didn't come up with anything. What did you say? They are positive numbers. And what do we do that always has to be positive numbers? Measure distance, right? So these are measuring a distance, 5 and 4. What are we measuring the distance from? 0. Okay, we got there. You got halfway there. Okay, that was good. So anytime we talk about an absolute value value, we are talking about the distance from 0. So how is that going to affect a a complex number? Okay. When we talk about the absolute value of a complex number, we are talking about the distance from 0, which is right here at the origin of the complex plane. So what we need to be able to figure out is that distance right there. How might we be able to figure that out? The Pythagorean theorem. We know that the absolute value of 3 plus 4i is going to be the square root of 3 squared plus 4 squared. Notice how I did not use 4i, I used 4 because that is the vertical distance from the origin. I is just representing that it was on the imaginary axis. Okay? Does that look familiar?
Yes.
That's exactly how we found magnitude of vectors. What is the absolute value of 3 plus 4i?
It's 5.
It equals 5. Okay? Use the real and imaginary parts to plug into your Pythagorean theorem, and we have our distance from 0. So you try. At your table, please find me the absolute value of negative 5 plus 2i.
Okay.
Check with a neighbor when you get it. All right, Guy, what is the absolute value of negative 5 plus 2i? Radical 29. Do you agree or disagree?
Agree.
Okay. 5 squared is 25. 2 squared is 4. Okay. Please make sure that you're not throwing I in there. Okay. You're just throwing the coefficient of I in there. Okay. All right. Now, I keep talking about trigonometric complex numbers, but we haven't really done a whole lot of trig yet, have we? Okay. The trig form of a complex number. This is big. Please write down or draw, I suppose, this picture for me. Okay? We have a trigonometric complex number where we have to travel horizontally A, vertically B, and then R is representing that absolute value that we just got done talking about. Okay, so we know that R is the square root of A squared plus B squared. R is just representing the absolute value of the complex number. Okay? Okay. Now, what about this theta right here? If we had a plus bi, how would we determine theta? We would take the inverse tangent of b over a because we know that the tangent of that angle is the ratio b to a. Does that look familiar? Yeah. Okay, it's just like working with a vector, except we don't have a vector, we have a number in the complex plane. Okay. So here on the next slide, I am going to ask you to take a number and write it into trigonometric form. Well, what does trigonometric complex form look like? Okay. Well, let's take this picture and let's write a and b in terms of some trigonometric function. Okay. We've already talked about the tangent. Okay. We know that the cosine of theta is the ratio a over r. And we know that the sine ratio is b over r. So if we wanted to rewrite a plus bi, instead of a, oh my, this is so far down. Instead of a, we could write r cosine theta. Because when I solve for a, this r would get multiplied over. A is the same thing as r cosine theta. And b is the same thing as r sine theta. So instead of writing bi, we can write r sine theta times I. This, highlighted, bold, circled, starred, whatever you need to do, is a trigonometric form of a complex number. Yes, the I is coming before the r sine theta, just so that I doesn't get scrunched inside of the angle when you write it in trigonometric form. But when it is in standard form, a plus bi, that number would come before I. In trigonometric form, the I would come before the breakdown of b. Okay. I'm not going to be super picky about that if you write it the other way. In trig form, I'm not going to throw a fit. But this is how the book is going to write it, and this is how the problems that I ask you, like on a worksheet review test, that's how they are going to look like. Okay? So let's go both ways. Let's take a standard form number and put it in trig form, and let's take a trig number and put it in standard form. Are you ready? Let's do it. Ready as you'll ever be. Okay. Please write down the number, -5 plus 6i. So the first thing we need to find is the absolute value. Remember, we labeled that as the r. Okay, that's just the -5 plus 6i. Okay, and when we find the absolute value, we need to take a squared plus b squared under that square root. What is it? Square root of 61? Yes. Okay. Now, just very quickly, I'm going to throw this up here. Oops. Here's our complex number. Okay. -5 plus 6i. Do you agree with where I plotted it? Okay, so now let's set up to find our angle. We know that the tangent of theta is b over a. So in your calculator that's in degree mode, please take the inverse tangent of 6/5 or -6/5. Either one would be fine. What do you get? 50.19. Is the angle of this guy 50.19? No, because that is in the second quadrant. Just like we did last week. Since this coordinate is in the second quadrant, we are going to need to take 180 minus that 50 point, what did you say? 19. Okay? So our angle is really 129.81 degrees. Okay? Really, we've done all the same math from last week, wouldn't you agree?
Yes.
Okay. So our trigonometric complex number becomes r cosine theta plus I times r sine theta. Okay. I hope you are recognizing some similarities in the work that we're doing and the order in which we're representing our number, right? Okay. Questions? Let's go the other way. I'm going to ask that you write down this trigonometric complex number. Kind of. Now I know that this looks slightly different. What did I do here that's slightly different from the other trig numbers that I've shown you? Okay, that r got factored out. I want you to be aware that that could happen actually quite often, especially in your bookwork today. So I wanted you to see what that looks like. So this is actually like the easy way because all we have to do is evaluate. Okay. I want this in standard form. So I don't want the cosine of 313. I don't want the sine of 315. I don't want the sine of 315. What is the cosine of 315? Say aloud, Dallas.
Square root of 2 over 2.
Square root of 2 over 2 plus I times, what's the sine of 315?
Also.
Negative radical 2 over 2. So our our standard form complex number is 3 radical 2 over 2 minus 3 radical 2 over 2 I. Notice how now the I comes after B when we're in standard form. Okay. I also want to show you one more thing before I talk to you about multiplying and dividing these numbers. Okay. How many of you think that this is a lot to write out?
Yep.
Yeah.
Okay, what if I told you that there's like shorthand for it?
I'm down.
Okay. So you could also write this number as RCIS theta.
6. Kiss.
Thank you.
Kiss.
Oh.
Yes. don't know why it says Tuesday. It has today's date on it though, so I think you're good. Is it for both days maybe?
Well, I'll be gone for a while, but
Okay. Oh, like through Tuesday maybe.
yeah.
Okay, so this is just like the R, cosine, I, sine, because that's the order in which you see it, and then the angle theta. So this is just the shorthand. You don't have to choose to write it like that, but I just want you to understand that this means the same thing. Okay? All right, so we're going to talk about how to multiply and divide these numbers. So what I'd like you to do is first write down that these are our two numbers. They're two trigonometric complex numbers, z sub 1 and z sub 2, and everything's just written as subscripts so we can keep track of which one's our first complex number and which one is our second complex number. So let's talk about if we had complex numbers that were in standard form, and don't write this down with me, let's just think about it together. If I had a number a plus bi, and I had a number c plus di, how would we have to multiply those together?
Foil.
You would have to FOIL them. You would also get one term that had an I squared, and we know I squared is -1, so you'd have to change that and then add it into the real part of the product. Okay? So it's like maybe a 2-step problem, maybe 3 steps, depending. Okay? If our complex numbers are in trigonometric form, then all we have to do... Okay, just look at it first. What's happening to the R's? They are being multiplied. What's happening to the thetas? They're being... Okay, so what is that? Thank you. So we multiply R, we add theta, and then we're done.
That was hilarious for a second.
Write it down. It looks more complex. It's going to take you longer to write this down than it is for us to do a problem. Okay?
That was pretty funny. Like, look at this.
It's so much simpler. You guys need to trust me a little bit here.
No, it's aggressive. Oh God,
It'd be mine, yeah.
She's slowly moving that down.
Oh, I don't want you to see it yet.
This one won't do.
I bet it's the same thing, but like almost different.
Yeah.
Like,
Okay, hang on to that. I get what you're trying to say.
yeah, like I feel like.
Okay, let's talk about a quotient. Just think with me here. Don't write this down unless you don't remember it at all. If we are in standard form and we have a quotient, what is our strategy?
No.
You gotta multiply
By the conjugate.
Conjugate. I was just gonna say the bottom.
I was never second.
Okay, so we have to take the denominator's conjugate and multiply the numerator and denominator by that conjugate. And then do all of the work and simplify blah, 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 blah. Emily, I'm going to come back to you. It's probably the same, but a little bit different. What did you mean by that?
Well, I figured like the R's are being multiplied in the front, but maybe they're divided in the front instead.
Okay. And what about our thetas?
I feel like they're subtracted.
Wow, look at that.
Wow. I'm really good.
Hey, I had a kid reading A's.
Emily just
Same
had this
today.
vision.
I thought about it.
But isn't it nice that they are so similar?
Yeah.
Right? Not as much to memorize for you. Eh? Okay, so please also make the note below. If you're going to leave your number, or if I ask you to leave your number in trigonometric form, then that angle better be between 0 and 360. No negative numbers, and no negative angles, and no angles over 360. So you may have to use that concept of coterminal angles to adjust your answer if needed. I'll show you what that looks like. You're going to highlight it? You're so responsible.
It's been a while. Stainless steel spoon. Stainless steel is
Okay. Are you ready for 2 examples? I'm ignoring you.
You're ignoring guy.
Oh, wait, no, well, sure. Okay, write it down.
He said, Marcus, stainless steel spoon like a Sharpie. Stainless steel is stainless or permanent marker.
Yes.
It's not my joke. I didn't say it.
Thank you for thinking of that for us. Okay, so notice how I used the shorthand here. You don't have to use the shorthand. If you want to write this out in the long form, be my guest. Okay, I'm just trying to save you a little pencil lead. Okay, so what are we doing with these 2 numbers? Okay, which means with our R values, we are also going to multiply. And with our angles, what are we going to do? What is 315 plus 120?
Oh no. 435.
435. I will not give you full credit for that answer. I would like you to find the coterminal angle of 435. So subtract 360 and we get 75. That's the answer that I want. Or if you'd like to write 24 cosine 75 plus I times 24 sine of 75. If you like that form better, I'm fine. Okay? Last example.
Oh, good. What is that?
Okay, what do we do with the R's?
Divide.
Okay. So we divide 15 by 3.
Yeah.
Good. And what do we do with our angles?
Original.
We subtract them. So we have 5. CIS, what's 240 minus 135?
205.
2
Oh, 105.
No, 105. It's 135.
Oh, now I'm like frozen. Oh, cool. Okay.
Why'd you scream this woman?
I can't have the wrong answer. Frozen on my screen. Don't answer the phone. Okay. So you have a green piece of paper. So we've had a lot of giggles today, which I appreciate, but I also want to make sure that you understand what's going on. So, in the 9 minutes that are left in class, I want you to do these 5 problems and get them checked by me. This is how you are leaving today.
Oh, are you
Do
kidding me?
these problems so that you can leave.
Wait, so
What if I don't
I
know
believe
these?
this process
I
is gonna
don't
stay here for
understand
the
the whole
whole.
video.
Well, Riley,